Hello and welcome back to Unit 13. In this second part, we're going to look at some examples with rolling motion and how to apply what we learned in the last part. Our first example involves a spherical ball rolling without slipping down an incline of 50 degrees. And it wants to know, can it do this if the coefficient of static friction is 0.8? To check this, we use the formula we derived that the static friction has to be greater than or equal to the tangent of the angle of the incline divided by mr squared over the moment of inertia of the center of mass plus 1. Since this is a spherical ball, the moment of inertia about the center of mass will be found by 2/5 times the mass times the radius of the ball squared. So that's 2/5 times 1 kilogram times 0.05 meters squared. And that works out to be 0.001 kilogram meters squared. I can now plug in to my formula for the coefficient of static friction, tangent of 50 degrees divided by 1 kilogram times 0.05 meters squared divided by 0.001 kilogram meters squared plus 1. And this works out to be 0.34. If we compare 0.34 to the provided 0.8, we see that yes, 0.8 is indeed greater than or equal to 0.34, and therefore we can roll down this incline without slipping. The next problem involves a solid cylinder rolling down a 20-degree incline without slipping. We are going to assume that the cylinder starts at rest, and we want to know how long does it take for the cylinder to reach or to roll 10 meters down. First off, it is a solid cylinder, so the moment of inertia is 1/2 times mass times the radius squared. So that's 1/2 times 0.5 kilograms times 0.25 meters squared. And that works out to be 0.0156 kilogram meters squared. Now that I know the moment of inertia of the center of mass, I can find the acceleration of the center of mass. That's g times sine theta divided by 1 plus the moment of inertia over mr squared. Plugging everything in gives that the acceleration of the cylinder is 3.35 meters per second squared. Okay, so now what I have is I have an incline. Here is the 20-degree angle. The cylinder is going to start here, and the distance between is the provided 10 meters, and the acceleration is going to be down the incline. This is a one-dimensional kinematic problem. The acceleration is 3.35 meters per second squared. Initial velocity is 0. We do not know how fast it's moving at the bottom. I'm free to put my 0 position anywhere, and I'm going to put it at the top, and that leaves my final position to be 10 meters. I can now use the formula x equals x naught plus v naught t plus 1/2 at squared to solve for the time. Both x naught and v naught are 0, so these terms go to 0. So 10 meters equals 1/2 of 3.35 meters per second squared times t squared. And this works out to be t equal 2.44 seconds. In the last example, we are going to have the same cylinder rolling with slipping down a 20-degree incline. You're given the coefficient of friction. You want to know the again, how long does it take, and what is the angular acceleration. Okay. The cylinder setup here is the same as for the last example. So the moment of inertia of the center of mass is again 0.0156 kilogram meters squared. The acceleration of the center of mass is found, again, we derived this formula in the last part, is g times the quantity sine theta minus the coefficient of kinetic friction times cosine of the angle. Plugging into this gives a acceleration of the center of mass of 0.59 meters per second squared. Given that this is the same setup as the previous one, we are again going to go to projectile motion. Some values change. Assume initial position will be 0, final position will be 10. Initial velocity of 0, again, starts from rest. Our acceleration is 0.59 meters per second squared. And we want to find time. So x equals x naught plus v naught t plus 1/2 acceleration times time squared. Initial position, initial velocity are 0. Therefore, I can get rid of those terms. 1/2 times 0.59 meters per second squared times time squared. And that works out for t equal 5.83 seconds. The other part of this problem wants to know, what is the angular acceleration? The angular acceleration, alpha, is the radius of the cylinder times the coefficient of friction times mg cosine of theta divided by the center of mass. Again, this formula was derived in the last part, and plugging in gives 0.25 times 0.3 times 0.5 times 9.8 times the cosine of 20, and we divide by the moment of inertia, 0.0156. 22.14 radians per second squared. Let's take for a moment and compare the acceleration of the center of mass to what the acceleration would be if this were rolling without slipping. So here I'm going to use that ACM equals R alpha, which doesn't apply to this problem as it's written because it is rolling with slipping. But for comparison purposes, I think it is helpful. If this were rolling without slipping, then the acceleration of the center of mass would be the 22.14 radians per second squared multiplied by the radius, which is 0.25, and that would work out to be 5.53 meters per second squared. So you can see it is very, very different rolling without slipping versus rolling with slipping.